Students, so in this video we will be solving the MCQs of chapter number 10, that is wave optics, right. See the first one, astronomers call the increase in the wavelength due to Doppler's effect. This is already given in your book, theoretical one. The increase in the wavelength is known as redshift, right, and decrease in the wavelength, if they are asking you that what is the decrease in the wavelength, then it will be blue shift. Presently we are being told to calculate, we are being told to call the increase in the wavelength. So increase in the wavelength is known as redshift. Clear? Okay. The next one, second one, two slits are made 1 mm apart and a screen is placed 1 meter away. So the distance between two slits, that is small d, is equals to 1 mm and capital D, that is the distance between the slit and the screen, is 1 meter. What is the fringe separation with a light of 500 nanometer? Green light of 500 nanometer is used. That means wavelength is given 500 nanometer and we have been told to calculate the fringe separation. Why? Fringe separation is lambda d by d, distance between two bright or dark fringe, that is fringe separation. Substitute, the values are already given, 500 nanometers, so 5 into 10 raised to minus 7 meter, d is 1 upon 1 mm minus 3, okay. So this will be 5 into 10 raised to minus 4 meter, okay. So 0.5 mm, 0.5 into 10 raised to minus 3 or 5 into 10 raised to minus 4. So A is your correct option. Clear? The next one. Okay, third one, light of wavelength 6000 angstrom is coming from a star. What is the limit of resolution of a telescope whose objective lens has a diameter of 100 inch? Limit of resolution, that is delta theta, is nearly equals to 0.61 lambda by A. This is the formula given in your textbook. Clear? 0.61 lambda upon A, where the diameter is 100 inch, diameter of the lens, that means this is 2A, this is already given as 100 inch, okay, and 1 inch is 2.54 centimeter. We are having 100 inch, sorry, 100 inch, so it will be 254 centimeter, right? Clear? So this will be equals to 2A, this will be equals to 2A. So A will be equals to 254 upon 2. So this will be 127 centimeter. Clear? Substitute in the equation. So delta theta is nearly equals to 0.61 into lambda 6 into 10 raised to minus 7 upon 127 centimeter into 10 raised to minus 2. Solving this, you will get this answer, 2.9 into 10 raised to minus 7. This is the equation for calculating the limit of resolution. So A is the correct answer, 2.9 into 10 raised to minus 7 radian. Fine. The next one, fourth one. For what distance is ray optics a good approximation when aperture is 3 mm and wavelength is 500 nanometer? Well, we are having Fresnel distance, right? The distance up to which ray optics is valid. That means all the concepts of ray optics can be used. So Fresnel distance is d square by lambda. This is the formula to calculate this distance. Now already d is given to you, 3 mm. So it will be 3 into 10 raised to minus 3. The whole square upon 5 into 10 raised to minus 7. Okay, so this will be 9 into 10 raised to minus 6 upon 5 into 10 raised to minus 7. So this will be 9 by 5 into 10 raised to 1, that is 10. 9 by 5, that means 1.48 into 10, so that is 18 meter. This is the distance up to which ray optics is a good approximation. So D is your correct option. Clear? The next one. Fifth one, unpolarized light is incident on a plain glass surface. What should be the angle of incidence so that the reflected and refracted rays are perpendicular to each other? Okay, since it is incident on a glass surface, so glass will have a refractive index 1.5 and we want the angle of polarization, because the question says what should be the angle of incidence so that reflected and refracted rays are perpendicular to each other. So when angle of incidence is equals to angle of polarization, right, that time the reflected and refracted rays are perpendicular to each other. Okay. So basically we have to calculate the angle of incidence, that is I. So according to Brewster's law, n is equals to tan theta p or n is equals to tan I. So n is given 1.5, this is equals to tan I. So incident angle is tan inverse 1.5. So that is nearly 57 degree. So this is your correct option. Clear? This is Brewster's law. N is equals to tan theta p. Theta p is angle of, it is angle of incidence equals to angle of polarization. Clear? The next one. Sixth one, interference is possible in both the types of waves that can undergo interference and diffraction. But polarization is possible only for transverse waves. Right? Presently, we have been told to say that interference is possible in, so answer should be both. C is the correct option. Clear? The next one. Seventh one. What is the shape of the wavefront for a light diverging from a point source? Generally, for a point source, the wavefronts are spherical in nature, right? Nearer to the source, of course, the wavefronts are spherical. At a far away distance from the source, these wavefronts will be plane, almost plane. But here in the question, they were asked to tell the shape of the wavefront which is diverging from a point source, so it will be spherical in nature. If in the same question, if they are asking what is the shape of the wavefront for a light diverging from a point source at a very far away distance, right, then it will be plane. Clear? At present, in the given question, your option will be A, spherical. Fine? Okay, the next one. Okay, the eighth one. If refractive index of glass is 1.5, find Brewster's angle. This is the question of your textbook. This is very easy. N is equals to 1.5. Right? From Brewster's law, N is equals to tan theta p or tan of I of p. So tan theta p is equals to 1.5. So theta p will be tan inverse 1.5. So this will be nearly 56.3 degree. So C is your correct option. You just have to substitute in this formula. Clear? Fine. The next one. Ninth one. If the distance between two slits is halved and the distance between slit and screen is made doubled, so fringe width will become dash. Fine. See, fringe width means distance between two consecutive bright or dark fringe, right, which is given by the formula beta equals to lambda d by d, right. Fine. Presently, it is given that distance between two slits is halved. That means new distance is half of the original. Small d is made half and the distance between slit and screen is made double. That means d dash is made 2 times of d. So then new fringe width will be lambda d dash by d dash, right. So this will be equals to lambda into 2d, this will be capital D, okay, upon d by 2, right. So finally beta dash new fringe width will be equals to 4 lambda d by d. This 2 will go in the numerator. Okay, but what is lambda d by d? Original fringe width. So your new fringe width will be 4 times the original fringe width, right. So fringe width will become 4 times. That means D is the correct option. Clear? Okay. The next one. 10th one. Refractive index of glass is 1.5. N is equals to 1.5. What is the speed of light in glass? And speed of light in vacuum is given as 3 into 10 raised to 8. That is speed of light, which is 3 into 10 raised to 8 meter per second, but it is in vacuum. Okay. So again, refractive index is equals to ratio of speed of light in vacuum upon speed of light in any medium. Okay. So V is equals to C upon N. We need to calculate the speed of light in glass. So this is equals to 3 into 10 raised to 8 upon what is N? 1.5. So this will be 2 into 10 raised to 8 meter per second. That means B is your correct option. Clear? Fine. The next one. 11th one. Estimate the distance for which ray optics is a good approximation for an aperture of 4 mm and wavelength 400 nanometer. That means we have to calculate the Fresnel distance, right? See, D is equals to 4 mm and lambda is equals to 400 nanometer. Okay. So for Fresnel distance, Z of f is equals to D square upon lambda. D is equals to 4 mm. So that is 4 into 10 raised to minus 3 the whole square upon lambda 4 into 10 raised to minus 7. Clear? So this will be equals to 16 into 10 raised to minus 6 upon 4 into 10 raised to minus 7. So this will be 4 into, this will be 10 raised to plus 7. So it will be 10 raised to 1. So it will be 40 meter. Clear? Fine. So A is the correct option. Okay. The next one. 12th one. Which out of the two colors, red or violet, will travel slower in a glass prism? Which out of the two colors, red or violet, travels slower in a glass prism? Okay. So basically V is equals to F lambda. Speed is equals to F into lambda. F is the frequency which depends on the source, right? So V is proportional to lambda, right? Now wavelength of red color light is greater than that of violet because refractive index is less than that of violet, and refractive index and wavelength are inversely proportional, right? Refractive index of red is less, so wavelength of red will be more. Since wavelength of red light is more, velocity of red light will be greater than that of violet light. So in the question it has been asked which of the following will travel slower in a glass prism. So it will be violet color. Clear? So we have completed all the MCQs of this chapter, and in the next video we will solve the MCQs of dual nature of matter and radiation. Thank you.